Now we're going to take a look at the real math portion behind calculating acidic and basic solutions in terms of hydrogen ions and hydroxide ions. So have your calculator ready. You need to have a scientific calculator. You need to have the log functions and be comfortable with the exponents and working with them. If we take a look at an example like this, where we've got a certain number of hydrogen ions, and I want to just know if that substance is going to be acid or base. Okay, we know that an alkaline substance, a basic substance, is something that has a hydrogen ion concentration less than 1.0 times 10 to the negative 7. Okay, essentially that's saying that we have fewer hydrogen ions than we do hydroxide ions. That would be a base. Okay, so let's look at the focus question, and this next problem has the exact same question there. Okay, I can just eyeball this to see if it's going to be acid, base, or neutral, and then we can do an actual hydroxide calculation from that concentration. Keep in mind there are many ways to actually solve this. No one way is right or wrong, just some ways are faster than others. So let's look at some of this. Now, just eyeballing it, just looking at where this fits, we need to keep in mind our number line. When we see a number like 1.0 times 10 to the negative fifth concentration, we need to keep in mind if these are all exponents, okay? If this is 1 and this is 0 on the right-hand side, well, I have 1.0 times 10 to the negative fifth. 10 to the negative fifth falls right here. That means that it is closer. This is a number that is closer to 1 than it is to 0. That means that it falls, this number is actually let's see, 1, 2, 3, 4, 5. If I put in those zeros again, that means that I have 0.00001 hydrogen ion concentration. Okay? That's only times 10 to the negative fifth. If I'm over here times 10 to the negative 14, that would mean I'd have 0.000, and you'd have 13 zeros along the way and 1. That's not very concentrated for a hydrogen ion concentration. So just by eyeballing it this way, we can see that we have much more hydrogen ion concentrations than we do hydroxide ion concentrations. I would be able to just look at this and see that it was an acid. Okay, that number is greater than 1 times 10 to the negative 7. Now, we can do some other calculations with this to find its specific hydroxide concentration. The second part to this problem is, what is that hydroxide concentration? If we know this one rule, well, hydrogen ion concentration, the problem said this was 1 times 10 to the negative fifth. Okay? The product of your hydrogen and hydroxide will be always 1 times 10 to the negative 14. So I simply just divide both sides by 1 times 10 to the negative fifth, and I get my hydrogen concentration. So divide by 1.0 times 10 to the negative fifth, and I end up with an answer that would just be my hydroxide concentration. Don't forget your basic rules. 1 divided by 1 is 1. Okay? Now, when I divide exponents, I simply subtract. So 10 to the negative 14 divided by 10 to the negative 5. 14 minus a negative 5 is negative 9. So my hydroxide concentration is 1.0 times 10 to the negative 9. So real simple calculation there, real basic math you should be comfortable with at this point. Okay, so then we had some homework with that. Now, another thing that we can do with this is finding its actual pH. The pH scale is actually based on a negative logarithm of that hydrogen ion concentration. So let's take this 1 times 10 to the negative 5. Okay, we knew that that was going to be my concentration, so I'm going to plug in the number 1.0 times 10 to the negative 5. Now we need to be careful on this. My pH is going to be the negative log of that. Okay, so what I'm going to do is I'm going to distribute this, since 1 times 10 to the negative 5 is in the parentheses. I'm going to take the log of 1 plus the log of 10 to the negative 5. Okay, so I'm going to rewrite this problem. I'm going to distribute that out, and if I can get this to work, we can see how this looks. I'm going to distribute that out, which means the negative, see the log, negative is out in front here. The log of 1 plus the log of 10 to the negative 7. Now keep in mind, log, and if you look on your calculator, that 10x key is this exponent key right here. The log and this 10x are actually the opposites. They're the complement to each other. They're on the same key. So to do this, you just simply hit the log of 1. Okay, the log of 1 is 0. So if you type in, if you turn on your calculator and you have 0 on there and just hit log, it, that's all you get, the log of 0. Now some calculators will actually, you have to kind of manipulate a little bit, and we'll work on that in class a little bit. Okay, so the log of 1 is 0. Now if I take the log and I hit my second function log, okay, and then -7, okay. Otherwise, you might have to go, depending on your calculator, you might have to go second function and log, and we go, or you go -7, and then your anti-log, and then hit your log, you're going to get -7. So there's lots of ways to do this. You might have to type in the -7 first, then your 10x key, and then your log. You might have to do 10x and then -7, and then hit your log. But ultimately, you work on this until you get, for your calculator how to do it, you'll get an answer of -7. This and this are opposites, so you'll always end up with this -7 here. So 0 plus a -7. Now be careful, this negative is still out in front. So this becomes -0 plus the negative of a negative is a positive, so that becomes just 7. My pH for this is 7. In fact, if you have 1 times anything, okay, 1.0 times anything, that number is going to be 0. You can just look to this and automatically know what that pH is going to be. So if we take a look at this problem, I already know that the log of 1 is 0. The log of 10x is just 1, and then here's a -4. So if I just plug that in, I distribute that log, or -1 times 0 plus a -4 gives me just a 4.0. Okay, two significant figures there, so pay attention to those. So just looking at those examples, we should see that the answer should be 10. Okay. Now, this isn't that hard until we get to a problem like this. Now I don't have 1.0. Now I have 2.7. The same rule applies. Okay, I see my concentration. My formula is going to be the same. My pH is going to be the negative log of 2.7 times 10 to the -8. Put that in parentheses. Now I'm going to distribute this log to here. I'm going to rewrite the negative and then the log of 2.7 plus a log of 10 to the -8. Okay? Keep in mind that these are opposites of one another. They're antagonists, really. So this answer becomes -8. If I type in on my calculator 2.7 and I hit log, I ended up with an answer of 0.4314, we'll call it. Okay? Now, don't forget the negative out in front. Okay, we're going to add these two, which means I'm going to switch the signs. So 8 minus 0.4314. Okay, 8 minus 0.4314 is going to give me my answer in terms of pH. Okay, now what if I do this? This isn't that different of a problem, really. It's essentially the same thing. The only thing that's going to be different is that I don't have exponents here. Don't freeze. Don't forget what 0.0050 really means. 0.0050 really means 5.0 times 10 to the -1, 2, 3. Now all of a sudden the problem is exactly like the previous ones. My pH is going to be the negative log of 5.0 times 10 to the -8. I'm going to distribute my log to here. I'm going to distribute my log to here. So my pH is going to equal the negative of the log of 5. Okay, so I go to my calculator, I hit 5 and log. The answer is 0.698, and actually 6.99, 0.699 plus the negative. Remember, log and 10, the 10x are going to be opposites of one another. So this is going to be -3. So it's going to be essentially 2.7 for my pH. Okay, so pretty straightforward. Just don't forget to put it in scientific notation first. Okay, then I can just follow this and 2.30. I went 3 significant figures here. I should have gone 2 in this problem because these first 2 are not significant. These 2 are. So the answer really should be 2.3 for a pH. Okay, now let's flip it around. The pH of something is 6. Okay, what is my hydrogen concentration? Well, same real problem. Oops, as I get rid of this. Okay, my pH is still going, notice I use the same formula. My pH is going to be the negative log of my hydrogen concentration. I'm going to get the pH by itself, okay? Or I'm going to get the hydrogen ion by itself. So I'm going to switch the signs first. Essentially, I'm dividing both sides by a negative, okay? So log of hydrogen ion concentration equals -6. Then I take the anti-log. Essentially, I'm dividing both sides by log. You can't do that mathematically, so you have to actually multiply by its inverse. 1 over log is what you're multiplying by. That's where this 10x right here comes from. Okay, you just hit your 10x key of -6, and you end up with an answer of 0.000001. Okay, or 1 times 10 to the -6. Okay, so pretty simple with that. What if it's something like 3.70? Honestly, if it's just plain old 6, not a problem. Just eyeball it. You know the log of 1 is going to be 0. So it's just 10x anyway. So you just have to look at it. But what if the pH is 3.70? Okay? It's not a whole number. You can't just eyeball it. So I say, okay, pH is going to be the negative log of my hydrogen concentration. Okay? pH is the negative log of hydrogen concentration. Well, my pH is 3.70. That's going to equal the negative log of my hydrogen concentration. I'm going to divide both sides by -1. So -3.70 is going to equal the log of my hydrogen concentration. Okay? Now I need to divide both sides by log. Okay, that cancels there. Oops, you can't divide something by log, but you can multiply by its reciprocal, same thing. So I hit my 10x key. Okay, so all I have to do there is now I type in -3.70, and I hit my 10x key. And I end up with an answer of 0.000199526. Okay, so really just kind of keep that in mind. Just follow the steps, and you should be ready to go. Okay, and my board is not working once more, but that's quite all right. 0.0001956, which is, if I do my significant figures, 2.00 times 10 to the -4. That should be good enough for getting you through these problems.